So I'm going to be talking today about navigating our AI-enabled future in high-stakes domains. And I'll talk about what I mean by high-stakes domains, but you can imagine these are things like finance, healthcare, national security, and so on. So I'll do a couple things here. I'm going to first talk about how we can work together to assure the future of software development, software engineering, and AI engineering in this brave new world of AI-augmented technology. And I'm going to talk a little bit about how we used AI when I was the director of operational test and evaluation last year. What I'll be talking about, of course, generalizes to many more things besides testing and evaluation, as you'll see in a minute. I have lots and lots more material on this topic at my YouTube channel, which is available here, and I'll make sure that the slides are available after the talk, so you can click on the links at the bottom of the slides and find out more information. So let's first start by talking about how we're going to assure the future of software engineering and AI engineering. About 60 years ago, there was a famous movie called Dr. Strangelove with Peter Sellers, and the tagline for that movie was, "How I Learned to Stop Worrying and Love the Bomb." And I've decided to riff on that to say how I stopped worrying and love the bot. So we'll talk more about that. About 4 years ago or so, I was part of a study that DARPA and the National Science Foundation funded at Carnegie Mellon Software Engineering Institute, and we were thinking about what the future of software was going to be. So we wrote a report and has a roadmap and a vision, et cetera, et cetera. There were 6 areas that we focused on. I'm not going to go through them right now, but if you're interested, you can take a look at the report and find out what we were prognosticating about would become, the future of technology. The idea was to look about 10 to 15 years down the road. So we wanted to take a big view that was going to be visionary and going to last for a while. One of the things we said back in 2021 that we thought that the future in 10 to 15 years would end up with replacing our existing manual software development pipeline and practice with a pipeline that had humans and AI working together as trustworthy collaborators to rapidly evolve systems based on the intent or the programmer's perspective, not the nitty-gritty details. And we thought, wow, that's so visionary, that we're never going to see that in our lifetime. And then, of course, almost exactly 1 year later, in November of 2022, ChatGPT escaped from the lab. And unless you've been frozen in carbonite like Han Solo, you know that ChatGPT and other large language models are used to synthesize new and original content in a relatively conversational manner. So no big surprise there. Well, what was interesting was almost immediately people predicted that the end of the world was at hand. And you don't have to go very far. If you Google, "Is AI the end of the world?" you'll find out that we're doomed and we should stop developing AI for the good of humanity and so on and so forth. Well, if it turns out that this really is the end of the world, it's going to make it much easier to navigate our non-existent AI-augmented future. But to be honest, I think there's probably a lot of other things we should be concerned about more than AI. We should be concerned about being sucked into a black hole. I just read yesterday or a day before that 3 city-killing asteroids are going to strike Earth within weeks. So that's to worry about. There's obviously conflicts all around the world with nuclear-tipped nations involved. And maybe the biggest threat to the future of humanity is TikTok, where we're destroying the youth of America's minds with this. But seriously, so what we discovered after ChatGPT and other large language models escaped from the lab, we started thinking more carefully about our predictions on AI augmentation. And there were a couple of areas we thought about in the study. Since that point, we've thought further about this, and we've published this in various places. But what we basically came up with was a little taxonomy to explain the space. And the taxonomy has an x-axis, which is the degree of AI augmentation in the software development lifecycle, and the y-axis is the degree of AI augmentation for system operations, actually using it in operating systems. So for the most part, through the last 60 or 70 years, people have developed conventional systems that did not have AI using conventional software development lifecycle techniques. And a good example would be the work that Nalini mentioned earlier about ACE and DAO, which we were using for developing avionics mission computing systems to fly airplanes around. And those were all developed without any AI augmented tools. There were no AI augmented methods. There was no AI in the system really whatsoever. That's the way that the bulk of systems have been built for a long time. There's another way people are doing things, and this is really accelerating rapidly over the past 6 to 12 months, where you don't build AI-enabled systems, but you use AI-augmented tools. AI-augmented tools to review code, to generate code, to test code, and so on. And I've been teaching courses at Vanderbilt and elsewhere that demonstrate how to do this. And there's some videos and course material that shows how to do it. At the other end of the spectrum are systems that use AI, like YouTube, we'll talk more about that later, where they use AI for things like recommendation engines and content moderation and generating captions and so on. But historically, that software was developed and tested and deployed using conventional agile methods. And of course, where things are headed, and headed very rapidly, I might add, is AI-augmented systems built using AI-augmented software development techniques. So a great example of this would be self-driving cars that use machine learning algorithms for navigation and decision making, and the tool suites and methods are all AI-augmented as well. So the good news is that the barrier to entry to learn how to use these technologies is very, very low. And for the price of roughly 3 cups of expensive pumpkin spice latte at Starbucks, so about $20 a month or so, you can get access to some very powerful models, and you'll be metered a little bit with some of the higher end tools, but it's quite useful, and everybody is using this. I'm sure most of you there are using that as well. Of course, these tools are not flawless, and you have to adjust your expectations accordingly. There was an article written several years ago, I think it was about 18 months ago or so, by Peter Denning, who's a famous computer scientist, and he said some interesting things about what ChatGPT was generating at the time. Keep in mind, this was probably ChatGPT 3.5. And he said, I noticed a certain style to the documents that ChatGPT generates. Most of what it tells you seems like you've already heard it somewhere. No radical departures from what others have already said. Frequent excursions into nonsense, and speaks with great authority even when outputting nonsense. And I kind of chuckled when I read that, and I thought, gosh, that sounds a lot like me when I was a first-year PhD student at UC Irvine, because I didn't really know what I was talking about most of the time. I was very confident even when I didn't know what I was talking about. But mercifully, my teachers, my advisor, my fellow students, they worked with me to hone and shape and train me to think and be better as a scholar. And of course, that's exactly what's happened. So in the 18 months or so since Peter Denning wrote that article, these tools have gotten remarkably better, especially if you use them properly. And in particular, if you want to be successful with AI, you need to use the right models for the right tasks. You need to understand prompt engineering and prompt patterns. And of course, the most important thing that our generation has, because we were trained, most of us, I think, in the more classical way, that emphasized critical thinking, interpretive skills, and ways of being able to separate wheat from chaff. So that's super important. I worry sometimes that people who are 5 years old will grow up in a world where they never had an AI augmented tool to offload their critical thinking skills. But that's a topic we'll come to later. However, for now, we're better off thinking about AI as augmented intelligence rather than artificial intelligence. Augmented means you're supplementing, you're not supplanting, you're making things better by using these tools with critical thinking skills. So for those of you who are fans of the X-Men and Professor X, you'll recall Professor X, Charles Xavier, has this helmet he calls Cerebro, and it basically allows him to see further and be able to do various types of analyses that a normal person couldn't do. So it's kind of like having an exoskeleton to your brain. Another pop culture reference, you've probably seen the movie Top Gun Maverick, where there's a kind of a fight between people who fly airplanes the old-fashioned way with pilots and people who want to replace piloted airplanes with drones. And there's a great scene where the admiral tells Maverick, you're headed for extinction. People like you who do things the old-fashioned way are going to go away. And Maverick, of course, says, maybe so, sir, but not today. And that's kind of the way we are with AI. People are not going away yet. What's also important at this phase is understanding the consequences of making and detecting mistakes when you decide whether you want to apply large language models to whatever task you're doing. So here's a little diagram from an article that was written by my colleagues at the Software Engineering Institute, where they separate the world into lower risk tasks where you can easily detect mistakes, like dealing with personal productivity tools or entertainment software where using AI isn't really that big of a deal, versus higher risk tasks in the high stakes domains, medical devices, flight control, mission computing, nuclear power plant control systems. These are things that are higher risk, and it is very important not to use AI unsupervised in those environments. So let's talk briefly about the impact of augmenting the software development lifecycle with AI. You can obviously apply AI through many different phases in the software development lifecycle, and we'll talk a bit about the different phases and which ones I believe are the most relevant at the moment. I'll start out with a sort of obvious high percentage prediction, kind of like dunking in basketball. You've got a high probability of making a basket. Generative AI is having a remarkable and very disruptive transformative impact on the software development lifecycle. A good example would be the proliferation of AI tools for writing code to help to improve the efficiency and quality of building software by reducing cognitive load on programmers. And you don't have to go very far today to see many, many examples of this. And some of them are very popular and becoming very commonplace in professional practice. I've been applying these tools to my courses for the past several years and having just a delightful time, except it does make one thing harder, makes it harder to write assignments that students don't find ways to generate automatically with AI. We'll come back to that. But what's important to realize is that AI tools are relevant for other phases and other roles throughout the software development lifecycle. What's interesting also is that OpenAI claims to have an internal model that now ranks as the 50th best competitive programmer in the world. Not entirely sure what their methodology is for determining that, but they claim by the end of the year, this year, their model will be ranked number one. Again, whatever that means. But whether that's number one or number 20 or number 100, it's improving very, very rapidly. It's important to realize, though, that not everybody is equally bullish about the benefits of generative AI for building software. So there's an article from Bertrand Meyer, who's another famous computer scientist, who talks in June of 2023, about 2 years ago. His provocative title is AI Does Not Help Programmers. Now, there's certain things people have said over the years that didn't age well. So Thomas Watson Sr. in the 1950s or 40s, I think, said, I foresee only a demand for 5 computers in the world. Well, that didn't age well. There was a famous quote by Bill Gates in the early 1980s where he said something like, why would you ever need more than 640K of memory to write software? That didn't age well. Claiming that AI does not help programmers, that did not age well. So it's important not to be overly optimistic and Pollyannic, but people who don't think AI was useful missed the mark in several important ways. First, people sometimes don't have a bigger view of how we deal with software development in the large. They just focus on a little piece. And we'll talk about that because it's important to see the bigger picture to understand the real value to developers. People also, especially a couple years ago and even today, used AI tools incorrectly, or they used the wrong version of the tools. So there were some articles written a couple years ago about how ChatGPT wasn't that great as a code analyzer, but they were using version 3.5 of ChatGPT, which wasn't great. If you use the latest versions, it's very, very good. People also often fail to apply proper prompt patterns and prompt engineering techniques. We'll talk more about prompt engineering later, but basically it's just using, prompt engineering in the small is using structured interactions with large language models to solve complex problems using natural language as opposed to code. Another problem is people often have an unrealistic expectation about how long it takes to master the learning curve of AI. They sometimes have this belief that if you don't get it right the first time you prompt, that the technology is pointless and will not help programmers or not help software engineers. That's kind of like saying if Michelangelo didn't create the Pieta with 1 or 2 blows of his chisel, that he was not a good sculptor. Well, it took a while to do something with that degree of expertise. I've coined a phrase I like to use called degenerative AI, which I claim occurs when pundits dismiss generative AI based on only 1 or 2 use cases that don't leverage the powerful tools and don't use proper prompt engineering or prompt patterns. Another concern people have is that the high-tech workforce will be decimated. And this is not an unfounded concern for all kinds of reasons. There's concerns everywhere, but especially in high-tech because of the rate at which these technologies are improving. My take on this is that AI is unlikely to take your job, at least not right away, but somebody who knows AI better than you do may take your job because that's where things are heading. And it's really remarkable if you look around, especially in the Washington, D.C. area with all the reduction in the workforce and so on. There's a lot of pressure to reduce the software development workforce by 80% and outsource everything to AI tools. I think that's probably premature. I don't think we're there yet. However, people are moving in that direction, and people who know how to use these tools are going to have quite an advantage over those who don't. There's something else to think about for a little further down the road called the Jevons paradox, which is something that's been true for a long time, where an increase in technology sophistication is then matched and actually increased by a greater need for workers because there's an expanded growth in market demand for better tools. A great example of this that we're all familiar with is what happened when we moved from assembly language programming to Fortran, to C, to C++, to Java, to Python, et cetera, et cetera. Every step along the way, people thought, gee, we're going to have no need for programmers because the managers can write the software in Fortran rather than assembly code. And of course, what really happened was it got easier to develop more complex systems, and people's demand for more complex systems quickly increased faster than our ability to provide talented workforce to meet those needs. There still is a question as to whether that trend will continue, but I'm quite optimistic because I think we're going to keep building more and more complex systems. However, the thing that's going to change is that people who are building these systems and people who are doing the lifecycle management and the requirements engineering and the certification and the testing, they're going to have a new set of skills. They're going to have to understand prompt engineering in the large. We'll talk more about that shortly. They're going to have to understand how to train and test large language models. They're going to need to learn how to deal with non-deterministic outcomes and outputs, which is really a challenge, especially in safety critical domains where people are accustomed to quite a degree of determinism and predictability. So the bottom line here is that in this brave new world of AI, the best programmers and the best software engineers won't necessarily be ones that can write code the fastest. It's going to be the ones who can orchestrate software projects using many different tools and making them work together. This has already been the case without AI, but AI accelerates and accentuates this trend because these tools are so much more powerful than even groups of people. So the bottom line, software professionals, people like us, researchers who have proficiency with generative AI are going to have a huge advantage over those who don't. There's actually a sports festival called the Enhanced Games. And the idea of the Enhanced Games is rather than trying to pretend that athletes who compete in the Olympics or other big sporting events aren't using performance enhancing drugs, instead say, let's throw out drug testing, and whoever wins is going to have the best genetics, the best training ethic, the best nutrition, and the best performance enhancing drugs. And that's kind of the way we're heading with AI, I believe. Well, let's talk about some of the challenges we're facing here. So let's first talk about thinking more holistically about the software development lifecycle. Most of the work, a lot of the work that's gone on to date with AI has focused on downstream phases, things like implementation, coding, testing, and so on, which is not surprising. If you look at papers you can find on the web and at arXiv and so on, you'll see many, many papers that talk about using large language models to write code, to sustain code, to benchmark code, to test code, and so on. And that's great. The problem, however, is that in the domain of coding and testing, the measure of success is perfection. If you had a compiler that generated really efficient code, but it was only correct 95% of the time, you probably wouldn't use that compiler because you couldn't risk the mistakes, even though it was usually very fast. Same thing's true with programming tools that write code. You have to be careful because if they're not perfect, then you've got a big problem on your hands. Therefore, I think it's more effective at the moment to think about using these tools for other phases in the life cycle. So using tools to help with requirements analysis, help with design and architecture, helping with deployment, helping with sustainment and maintenance and improvements. And there's lots and lots of artifacts throughout those phases that are textual in their core or based on diagrams. And it turns out that these AI tools work really, really well, especially because the comparison point is not perfection, it's utility. You just have to have the tools be better than what we have today, which are groups of people working together. And as you know, whenever groups of people work together, they get tired, they get sloppy, they have inconsistencies in what they're doing. And so these tools are actually much better at that. So what we've found so far in the work that I've been doing with my colleagues at the Software Engineering Institute and at Vanderbilt is that a lot of these non-code artifacts, in other words, not the source code, but the documentation, the requirements, the specifications, the regulatory documents, and so on, these can be analyzed at scale by augmented intelligence tools much better, faster, cheaper than by humans working alone. There's a couple of examples here. We refer to these as analysis of document inconsistency, incompleteness, and discrepancy, or DID. And we took a look at some specifications that were designed for nuclear safe software, where obviously safety and reliability are super important. And we found that the documents themselves contained inconsistencies and discrepancies, even though really smart people had worked on them for a really long period of time. And that's just because whenever you've got more than about 2 or 3 people writing a document that gets longer than about 20 pages, very few people can keep it all in their heads. So tools are much better at finding inconsistencies, especially across documents or between different parts of large documents. So large language models are very well suited for doing this. And we've written some papers on this. And I think this is going to be an area of tremendous growth, automating other phases of the life cycle. The other thing we're seeing, of course, is we're seeing better AI tooling throughout the software development life cycle, both with things like retrieval augmented generation, which tries to do a better job of matching queries to pre-digested results that are known to be correct or known to be valid. And then, of course, all the new tools that are coming out from OpenAI and Google and Anthropic and so on that integrate many other tools and services. It's really remarkable if you take a look at what's coming down the pike, especially with the forthcoming ChatGPT version 5. They're going to have some really cool tools that will make it easy to do lots of different things. Coding, analysis of documents, videos. I use this kind of stuff all the time with my work every day, and it simplifies my workflows considerably. Something else that's very important, especially in high-stakes domains, is being able to check for compliance with policies and standards using large language model-based static analysis tools. So there's various specifications for writing safety-critical code, like the MISRA standards. The SEI has some coding standards for C++ and C and so on. And a lot of this can be automated quite nicely. And we've done some analysis of this as well. And this, again, is a good example of document inconsistency, incompleteness, and discrepancy detection that can be used throughout the software lifecycle. There's also some other important things. I won't belabor this, but this is what I learned when I worked at the Pentagon the past year. Large organizations, large government organizations, end up with thousands or tens of thousands or hundreds of thousands of PDF files and Word documents and PowerPoint presentations and all kinds of other things. And they're really drowning in a sea of documents. And it's very difficult to be able to keep track of all that information. So one of the challenges, especially with the reduction in the workforce for the government, is being able to find ways of automating and using AI-based tools to do work that historically would have involved people plowing through large repositories. Something else that's super important that I'm a big fan of is formalizing the discipline of prompt engineering. And prompt engineering, there's a lot of confusion about this term. I like to differentiate between prompt engineering in the small and prompt engineering in the large. So starting with prompt engineering in the small, that's basically how we interact with large language models to get them to do our bidding using natural language and prompt patterns. What's really great about this, and I think this is a very important paradigm, is it focuses on problem solving and what Jeanette Wing used to call computational thinking rather than on traditional computer programming. And I have a video here you really should take a look at, recorded it recently, that talks about what I term the coming commoditization of computational thinking. So most people in the future will be doing computational thinking not with your favorite programming languages like Java or Python, but with large language models and AI. Within the development lifecycle, the ability to do prompt engineering is very useful for working with modern interactive development environments. So a great example would be Windsurf from Codium, or Cursor, or Copilot, which is not the Copilot that's in the Microsoft Office tools, but the one that comes from GNU. And this allows you to do development where you have a window on one side of your interactive development environment that's the code window, and then you also have the prompt window on the other part of the window interface. And you can basically refine your code by prompting. You can speak if you want. You can say it verbally, not having to type it in if you have carpal tunnel syndrome. And it's really, really, really powerful. I think that this approach, using prompt engineering in the small, is a much more appropriate model to apply computational thinking for non-computer science or maybe even data science professionals. So people who are doctors and lawyers and accountants and warfighters, whatever, they're going to be using these interfaces. And you can actually set up your large language models now to be essentially an operating system interface that you can interact with your computer and the rest of the world, either by typing or by speaking your commands. Very much like Star Trek. Something else that's important here involves codifying prompt patterns. I've been working with patterns now since the middle of the 1990s, so it's about 30 years that we've been working on patterns for software. And those of you who program are undoubtedly familiar with the concept of software patterns, which are basically reusable solutions to common problems that arise when you're building software. And they give you a template to solve a broad range of problems in other contexts. Well, it should be no surprise that there's prompt patterns which codify best practices for phrasing prompts to large language models to get maximum extraction accuracy and be able to transfer mechanisms and problem solve with large language models more effectively and accurately. So what I think is important is where we're headed is thinking about not just prompt engineering as a set of parlor tricks to get large language models to do our bidding as individuals, but what I like to call prompt engineering in the large, or holistic prompt engineering, where we're thinking about many other phases in the life cycle of building systems with AI or together with AI. Things like configuration management, maintenance, testing, release-to-release compatibility. And the reason this is so important is that we want to be able to build systems with AI that can last for long periods of time with teams of people and not be buried under a mountain of technical debt. And I think this is one of the key areas that we really have to think carefully about, because I don't think it's well understood yet. And I think a lot of people are using prompt engineering in the small, and they're not going to be able to scale up without a more holistic view. So let's kind of switch a little bit and talk about the impact of AI augmentation on systems operations as opposed to the software development lifecycle. So first thing to note is that AI augmented systems are really software reliant systems that have a mix of both AI and non-AI components. And right now, people focus on interactive AI with chatbots and so on, but there's tons and tons of other AI, computer vision being a very good example. What's important for the interactive model is that people are still in the loop for the most part. We want to make sure we have skilled prompt engineers, skilled developers, skilled subject matter experts who use the right tools and processes. A good example of systems that are doing this already would be falling under the category of socio or societal scale infotainment systems. There's a whole chapter in our national agenda for software study that talks about these kinds of systems. And these are all our favorite social media platforms like TikTok and Facebook and so on. YouTube is a good example of a multimedia content delivery platform that uses AI for all kinds of things, for recommendations, captioning, moderation, analysis, of course, advertising. And they're increasingly using AI internally to build these systems, but they were already using AI as ways of being able to make the systems more intelligent at scale. More interesting to me, of course, is using AI in mission-critical systems. These are systems where the right answer delivered too late becomes the wrong answer. And there's lots of examples that have been emerging over the past couple of years. There's something called the AI platform from Palantir. There's something from a platform called Donovan from Scale. And these are all platforms that are used for decision support, basically helping people make decisions, do planning, being able to help analysts look at satellite imagery and make sense of what's going on much more rapidly than they would if they had to rely on manual techniques. Now, of course, there are risks here because there's all kinds of issues with adversarial attacks and so on, but this is the way that the world's heading there. If you look at the Department of Defense kinds of systems, next generation systems, they're all about intelligent this, that, and the other thing. And you have people, say a piloted airplane, working to coordinate a swarm of unpiloted, uncrewed drones. Very, very complicated systems, hard to build, even more hard to test. So have to keep our eyes out to make sure that those are tested properly. One of the things to remember here is that these AI-augmented systems are different than those that don't use AI. And my colleague from the SEI, Ipek Oskaya, has a nice article from a year or so ago that talks about the differences between these. One of the most obvious differences is the fact that these systems are often intentionally non-deterministic. So for example, chatbots like ChatGPT and Gemini and so on try to be non-deterministic because they don't want to look like they're just giving you back the same canned response over and over again. They want to act more like a person, and that's good. Sometimes, however, we don't really want our systems to be non-deterministic. If you're trying to build a system to defend a ship or a city from attacks by drones or missiles, you really want to know what it's going to do and not have it just make things up on the fly and have terrible catastrophic results. There's also the challenge of emergent behavior, which is what we see a lot when we use large language models. It's often very difficult for even the developers of the systems to know exactly how or why the results were the way they were. And you end up with complex patterns that arise seemingly spontaneously from the interactions of much simpler elements or systems. I asked ChatGPT to generate me a diagram to visualize emergent behavior, and this is what it came up with. And then I asked it to explain why it was a visualization of the concept of emergent behavior. If you haven't played with ChatGPT or Gemini or Claude or whatnot to do image analysis, it's really fascinating because it does a very good job of being able to, quote, understand what things mean. And of course, the emergent behavior is what provides endless fodder for dystopian science fiction, starting with things like the 2001 Space Odyssey, where the computer goes berserk, to the Terminator series, where Skynet becomes self-aware and decides humans are a threat and decides to create the Terminators to destroy humanity and so on. I am not quite worried about that, but there are a lot of people, if you listen to the popular press, you'll see well-known people like Jeff Hinton, like Eric Schmidt, like Henry Kissinger, talking about how AI is going to destroy the world very rapidly. I don't necessarily subscribe to that, but it's certainly worth keeping in mind. Another characteristic that is important to be aware of is the extreme dependence on data. So the quality of the data, the quantity of the data, the depth of the data really determines how good the AI apps are going to be. So as always, garbage in, garbage out. But where this is important is we have to start thinking about testing of data in the same way we've historically thought about testing of code. People have not spent as much time in computer science doing research on testing of data as they have on testing of code, and that needs to change very rapidly. What also makes this important to realize is that data is now multimodal. So it's not just about text, it's about video, it's about audio, it's about code, it's about signals, and so on. And one of the consequences of that is we're not going to have to worry about there being an end to data to train on. There was some concern of maybe about a year or so ago, a year and a half ago, where people said, well, all the content publishers are moving their content behind paywalls, so there'll be no more content for AI to train on, and we won't ever have it get any smarter. That is patently not true when you take a look at the enormous number of videos and audio information that's generated in the form of podcasts and so on that are available through YouTube and TikTok and Instagram or whatever. There is no end to things to train on. Now, is it good data? That's a different story, but we're not going to run out of things to train on for a very long time. So what are the challenges and opportunities for these AI augmented systems? Well, some of the big challenges we have to deal with, and we have to deal with these now, involve trying to figure out what techniques and tools do we need to handle the life cycle of systems built using AI, ranging from specifying, architecting, designing, analyzing, testing, deploying, and sustaining these systems. And this is where things get really dicey, especially for systems in the high-stakes domains. There's a famous movie from many years ago called The Graduate with Dustin Hoffman, and when he graduates from college, one of his friends or his neighbors tells him, I have one word for you, plastics. And if I was going to kind of channel my inner graduate, I would say I have just 2 words I want to share. I want to say assured AI. That is the killer application for the new generation, figuring out how to do that. Why is that important? Because in high stakes domains, military, healthcare, and so on, we have to be very cautious how this technology is rolled out. For one thing, not everybody else is concerned with how safe and reliable software systems are. They don't necessarily care everywhere about having collateral damage. They don't care if something goes awry. And this is very challenging in the warfighting domain, but it's also challenging in other domains as well. People are often pushing things where they don't really know the consequences in the long run. Sadly, this is an arms race, and other parts of the world are moving very quickly to integrate generative AI into the military operations that they do. The US has been slower to do this. We've typically used AI primarily where humans are in the loop for doing things like image analysis and so on. But other parts of the world are starting to get killer robots and killer drones. With my hat on as the Director of Operational Test and Evaluation, one of the things I realized very quickly when I got there a year ago was that we have to continue to think about how to test our systems earlier in the life cycle, or better yet, prepare them for testing. This is often called shift left testing. So you try to go as early as you can in the life cycle. And the reason for that is pretty obvious. If you wait till the end to test these systems are inherently non-deterministic, and so if you don't get a head start on understanding their behavior throughout the life cycle, you're going to have a very hard time doing a single big bang test event at the very end or near the end before they're actually released and expect anything sensible to come from that. So here are some ways that we were using AI when I was the Director of Operational Test and Evaluation. So one thing we did was work on being able to derive test cases from relevant documents, from design documents, architecture documents, policy documents, requirements documents. And these large language models are very, very good at that because they're trained on analyzing large amounts of data. That's typically what they're trained on. One other thing we've worked hard on was ensuring that the tests align with the specifications from the outset. And this is certainly getting better, especially in downstream phases of software development. There's a whole bunch of products that have come out now. For example, there's a product called DiffBlue, which is used to be able to generate unit tests from software APIs. And that works very nicely. You can also use large language models to simulate diverse usage patterns in environments to test software under various conditions or various modes. So for example, one of the prompt patterns that's very popular is called the persona pattern. And you can read about the persona pattern in some papers that I've written over the years. So what you do with the persona pattern is you tell the large language model to think like a particular role. For example, act as a senior security engineer, or act as a senior safety engineer, or act as a senior reliability engineer. And what that does is it puts the large language model in the mode to do the analysis, so you're more likely to get results that relate to whatever you're about to ask it than if you just gave it the prompt in a more generic way. And that's really what prompt engineering is about, is being able to give the large language model the appropriate context so it can do a better job of meeting your needs. Now, the thing to note is that these patterns evolve, just like the patterns for writing object-oriented software are not necessarily the same patterns for writing functional software or reactive software. The patterns for prompting the standard large language models like ChatGPT-4 are not the same as the patterns for prompting the more recent models that do reasoning. However, there are still patterns, and you have to understand what those patterns are if you want the tools to work properly. Something else that's very valuable, especially in large organizations that have a large amount of data in various repositories, is to mine those repositories to help testers and test organizations, and quite frankly, developers and development organizations, to learn from prior projects. So you can continuously improve the testing process, the development process, by identifying common pitfalls and best practices. And this is really, really powerful. I think this is going to be an area that's going to be explored very, very comprehensively very soon, especially because of the downturn in people in many government jobs or contractor jobs. Something else that we did when I was there was we began to see if we could look at the documents we were producing. The DOT&E, the Operational Test and Evaluation Community, produces an annual report. And we've done this for the past 3 or 4 decades. And in this annual report is a summary of how all the systems that we test are doing. And what you can do if you have these documents and you have AI is you can analyze these documents in order to see trends. Are things getting easier? Are things getting harder? Are things getting better? Are things getting slower? And so on. And that kind of insight would be almost impossible for humans to do. It probably is technically or feasibly impossible. You could do it, but it would be enormously complicated, take a long time, require endless amounts of pizza and Diet Coke and so on. Something else we have to do if we want to be effective with building systems that are going to work under all circumstances is be able to perform quality assurance as the system is running. It's not enough just to do it before you field it. You have to do some testing in the field. There's other discussions of this in our national agenda study about assuring continuously evolving software, so I won't spend much time on that. But I will point out that there's some interesting tools that are emerging, like AutoGPT, that you can use to run results and run tests continuously in order to see whether the system is getting better while it's running. Naturally, there's lots of caveats here. Mission and safety critical cyber physical systems have to be thought of in a more refined and subtle way because they're going to not work and bad things are going to happen. But I think we're going to see a lot more AI used together with people to do things like scale up assurance case analysis. So let me go ahead and wrap up, and I'll be happy to take any questions. It's my perspective that using AI tools effectively, the current generation of AI tools, is a step towards the longer term vision of having a world where humans and AI work together as trustworthy collaborators. That may still be the 10 to 15 year horizon. I don't think we're going to have things completely trustworthy anytime soon. We're getting a lot better, but it's not going to be something where you just fire and forget and don't have to have a human thinking about what's going on. Where we want to go is we want to be able to code from a higher level. And I'm already doing this in my own workflows when I work as a dean or as a professor. I used to do a lot of things manually where I'm now relying or leveraging AI to do a lot of the grubby work. And it's really quite amazing how more productive you can be as a computational thinker as you learn to use these tools properly. And you also learn to look for the inevitable quirks and hallucinations that may occur. Why is this the case? It's because we're able to focus on problem solving rather than conventional programming with all of its wonderful accidental complexities, things like syntax and semantics, fence post errors, off by one errors, buffer overflows, concurrency control, synchronization, distribution. All these other myriad complexities are able to be dealt with in a more systematic way. Therefore, humans, us, are able to focus on the more interesting and architectural aspects of software development rather than wrestling with the low-level mundane details. By the way, if you want to have some fun, take winners of obfuscated C code contests and give it to your favorite large language model and see if it can figure out what the programs do. Sometimes they're surprisingly good. So my perspective here is that nearly everybody is now a natural language programmer. Not a programmer in the classic sense, not a programmer in the Java, Python, C, C++ sense, but we're programming large language models. And the good news is it's allowing us, if we do it properly, to be much more scalable and ultimately much more productive. And we've written a bunch of papers that are widely cited that talk about this kind of stuff. So to just kind of wrap up, there's still a lot of work that we have to do before we can get humans and AI to work together. But this is the time to jump in. If you do jump in, make sure you use the latest, greatest LLMs and use them wisely. This is the biggest transformation in the past 2,400 years. It's exciting. We are going to be part of shaping the future. I think that's kind of cool. But we have to be very sensitive to the forthcoming digital chasm. We've been worried about the digital divide for a long time, where some people have access to computers and the internet, some people don't. That's largely being addressed. It's not perfect, but we're getting there. The biggest chasm we're going to have, and it's already happening sadly in academia, students are coming to William & Mary, and I'm sure they're coming to other universities, who are so far ahead of the professors with respect to AI proficiency that they're bored out of their minds. And if we can't up our game rapidly, we're going to lose out. So there will be other people in the world who don't understand how to use this, and they're just going to get left behind like there's no tomorrow. The good news is that it's only been about 2 years before people started doing this, and therefore it's not hard to catch up. The tools are getting easier to use. There's tons of information available online on how to do prompt engineering and prompt patterns. And I've also seen some studies recently that show that people who are novices benefit more than experts from using AI. And I believe that. It's both scary and wonderful. It's great when I want to learn a new skill and go from being a novice to being at least a proto expert, a pseudo expert. I can come up to speed very rapidly. It's scary when my students can do that as well, and I have to work really hard to try to stay one step ahead of them in the classes that I teach. So that's the end of my talk, and I'm happy to take any questions.